Hi everyone, today I want to introduce a powerful technique known as the time-of-flight secondary ion mass spectrometry, or ToF-SIMS in short. Before I get into deep about the ToF-SIMS, I want to first introduce you guys with mass spectrometry. So mass spectrometry is simply a tool to identify and characterize chemical compounds based on their mass to charge ratio. It has three main components in it, which is first the ionization source, which create charged ions of the samples. Second, the ions are then accelerated and passed through a mass analyzer where they are separated based on their mass to charge ratio. And third is the ion detection system, which once the ions are separated, they will detect it based on their mass to charge ratio, and then it will be generated to a mass spectrum that represents the abundance of different ions. So now we can look back to ToF-SIMS. In general, ToF-SIMS is a surface analysis method that provides detailed insight into molecular and elemental composition of the material. And the way ToF-SIMS work mainly involved using a primary ion source, which will bombard on a target surface, and this will create the release of secondary ions, which can include fragments or molecular ions. And those ions will be connected and analyzed through the time-of-flat mass spectrometer. For the time-of-flat mass spectrometer, we can look at the equation here where time refers to the time the ions pass through the mass analyzer. And this equation highlights the relationship between the time and the mass to charge ratio, which we can think about: the heavier the ions is, the slower the more time it needs to go through it. And based on the difference for different ions or fragments, we can identify the mass of it. There are also several applications for ToF-SIMS, which we can use it for 2D images, mainly for the biological samples, or we can generate mass spectra, and we can also do the depth profiling, which is essential to understand layer by layer composition of the material, and it often involves sputtering out of layers of ions, followed by scan and analysis of the surface. There are also both strengths and limitations for ToF-SIMS. First, it is a highly sensitive technique that offers detailed information about the surface layer of the material. And second, it also has very high mass resolution. Third, we can do analysis for both insulate and conductive samples. For the limitation, first is about the sample preparation. It is important to ensure the samples is very clean, because since it's a very sensitive surface technique, any contamination and artifact can affect the final result. And second is the matrix effect, which can impact the data interpretation, where the sample matrix influences ionization efficiency and may also cause or affect the accuracy of the spectra. Third is the sample charging. So since we said the strength is that we can use insulate samples, however, insulate samples can also accumulate charges during analysis, and this can lead to distortions in the mass spectra and affect the reliability of the data. Despite those challenges, ToF-SIMS is still a very valuable technique for researchers to gain a deeper insight into the molecular landscapes of different samples.